Hi, everyone. It's Alan Shimel, DevOps.com, DevOps TV, and we're here in Las Vegas for IBM Think 2018. And I'm joined by Roland Koo from IBM's Z Systems or Z Enterprise Systems. Roland, welcome.
Thank you very much.
So, Roland, we were talking off camera, and we've been working a lot with the Z Systems, the Enterprise System Group at IBM, because as we were just talking about with the fellow from Urban Code, the whole DevOps on mainframe thing is real, right?
Yes.
It's become more real
Right.
over time. But you collaborated actually with one of our writers a month or so now, and we just wrote an article about COBOL programming. Nothing DevOps necessarily about it, but for whatever reason, it struck a nerve or a chord with a lot of COBOL people out there around the world, and it went kind of viral. And we got tremendous feedback on it, which just goes to show you that you could come to IBM Think and you could hear about quantum computing and AI and cognitive and all of these sort of, Star Wars next gen technologies, but there's still a lot of damn COBOL programmers out there.
COBOL is still running your business, right?
Absolutely. As is the mainframe.
Is the mainframe.
And another thing, it's been a very common theme in all of our discussions is, we've been hearing for 25, 30 years that the mainframe's going away. It keeps getting bigger and bigger and bigger. The latest generation was a phenomenal success.
Right.
And the fact of the matter is, as our next guests who are in the wings will testify, banks run on mainframes. The world's financial systems run on mainframes. And not just financial systems, healthcare, technology, government. There's a lot, when you get to a certain size, it's still the best platform for a lot of these things.
Yes, it is. And what we do here is actually, as a compiler group, I work in the compiler group, we're working very closely with the hardware guys, right?
Yep.
To design the specific hardware features that would benefit the COBOL applications. So, for example, in Z14, we actually jointly developed a unit called the Z vector packdecimal unit.
Okay.
Basically, that is to accelerate packdecimal applications. Instead of using the memory-to-memory instructions, we're actually using vector registers to do that. As a result, you're actually looking at very compute-intensive applications can go up to 94% faster.
Wow.
So basically, this is kind of the roadmap that we are laying out for the for the compiler versus working together with the hardware, because we run out of steam in terms of clock speed. So basically, in the past, where you just put install your application onto a new hardware, because the clock speed advantage, you can actually get it really run very fast. But now you really have to do something on your application, because the way that we deliver performance is very different. So really, you have to optimize the application. If you don't have the instruction set to take advantage of the hardware, you're just not going to get it. So that's really what we're doing, and that's how we actually keep advancing the hardware, right? And the compilers play a very, very big role of it.
Absolutely, absolutely. Now, but Roland, another common theme that we're hearing in talking to people here is this idea, and actually Sanjeev Sharma used the term, I want to say strangler theory, but I may be misquoting him, so I apologize. But the idea is that you have this sort of application. Let's say you have an application that runs on your mainframe, on your Z system, and you're going to peel off certain parts, maybe the UI or the user interface for end users. I'll put on a forward-facing cloud. My data stays here. My analytics, my engine, my compute engine stays here,
Right.
on the mainframe. And so, how does this work?
Well, so we understand that there's nobody going to write an application with one language anymore, right? So people are actually going to find the best language that fits their purpose.
Yes.
Right. So for COBOL, for example, what we do is we actually enable people to extend their applications to work with Java, work with APIs, work with Node.js. So we actually put in native JSON support, for example.
I know.
So basically, we're talking about extending the language to support this
Today's technology.
today's technology.
You know, in this, so Rosalind Radcliffe's a good friend. I speak to her all
Yeah.
the time. You know, when I first started with DevOps and DevOps.com 4 or 5 years ago, there was this notion of bimodal IT, where I was never a fan.
No.
I got to be
No,
honest
I'm
with
not
you.
a fan either.
You know, it was almost like, oh, these are the special kids who have to sit in the corner. They're a little slow, right? But the mainframe wasn't slow, and it wasn't. It was smarter than what's in the cloud. So the idea of that, you know, we had to treat the mainframe like a special needs child. It made no sense to me ever.
No.
Now, with what you guys have come out with recently in compilers and APIs, we can use, you know, all of the hot Ruby and JNode and Java and, you know, and hook into cloud systems and everything else. There's really, it's very hard for someone to stand up today and say, well, we run mainframe, so we can't do DevOps, or we can't go faster, or we can't automate. There's no excuse.
That's right. And on that note, we also are bringing in new technology, new languages onto the mainframe as well.
What are they?
We just announced a Node.js
Okay.
that is native on the platform,
Really?
running on ZOS. The advantage of that is really if you wanted to talk about digital transformation, you wanted to get into the API field. What you really wanted to really do is to get the people who understand the application to try to expose these APIs. And those skills resides on the mainframe, right? So by bringing this Node.js onto the mainframe, what you can do is you can actually do some orchestration of these APIs, using ZOS Connect or
Sure.
whatever. Then you can actually have one set of interface coming in, and then you get the right answer going out. So basically, everything will be co-located, with the data, with the critical assets, to increase efficiency, and also efficiency in terms of development.
Perfect.
Yeah, and
Perfect.
we're also bringing in Swift as well. So
Yeah.
yeah, we are. We're working on it, and
That would be cool.
that's already on Linux
Yeah.
on Z, but ZOS is coming soon
With native
for
Swift.
with native Swift for the
Excellent.
beta. So that's what we're doing.
Let me ask you one more question, I'll let you go.
Okay.
So the geek in me, went down on that floor and took a look at that quantum computer model they have up there. You may not know the answer to this, but what is it? What do you think quantum computing is going to mean for the mainframe?
I think quantum computing will be solving a different set of problems.
Different set.
Different set of problems. I think they'll be looking at more like not 0 and 1 or black and white problems, but maybe a lot of fuzziness into it. And I think they're going to be solving like a lot of AIs and all that. But for business logic, I still think that the mainframe is going to be king for a little while until we figure out what to do with the next generation.
The next generation mainframe, or something that
next
replaces
generation,
it?
something that could possibly replace the mainframe, right? Because we're talking about progress here, but that's going to be a long time.
Yeah, I think I'll be retired by then.
Yeah, me too.
Let's hope. All
Okay,
right.
thank you very much.
Roland, thank you for joining us. Roland Koo, IBM Z Enterprise Systems here from IBM Think 2018 Las Vegas. This is Alan Shimel, DevOps.com, DevOps TV. Have a great day, everyone.